So in our 7th instalment of differentiation at AS level, we'll be looking at problem solving questions. So believe it or not, there is a problem solving section on differentiation, and this usually implies working out the maximum or minimum values of a particular problem. And this is where it really comes into real life situations when you're asked to find the maximum the maximum value, or where it's most efficient, and that's usually based around a formula that has been derived for you. So more often than not, sometimes it's not explicit that differentiation is used in these words, so in a particular question. So it's always important to look out for keywords. So if you're asked to find the minimum value or a maximum value, then there is a good chance that it is going to revolve around differentiation. Now, if you are asked to find the maximum value of a particular expression, then what you then need to do is, first of all, find the values of where the equation is going to be stationary, determining what those stationary points are, whether they're max, minimums, points of inflections, and then once you've found the correct stationary point x value you're wanting, substitute that back into the original equation to find its either maximum profit or minimum value. In more cases, it's usually the maximum that you're looking for, because you're looking for a point where it's most maximum rather than at its minimum. Now, before you tackle each of these questions, some important notes that you kind of need to run through before you start a question. So the first things first is, as always, read the question carefully and what is being asked of you at each stage. Now, when it comes to these problem solving questions, some nice questions are kind of broken down into certain sections, i.e. A, B, C, D, before you get to the final point. Some larger mark questions, i.e. some more exam style questions that are worth 7 marks, might ask you straight to go to the maximum value, in which it's a case of working through your work in stages. The next part is your initial formula must only be in terms of one letter only. So for example, when we go through some example questions, you might have a formula that involves more than one letter. So for example, if I had A equals 2b plus 3h, I've got b's and h's in my expression, which I can't have. I've got to have one letter, because depending on what I'm differentiating with respect to, any other letters will just be treated as a constant. Sometimes a diagram might help, and more often than not, sometimes diagrams are given to you just to give you that helping hand. But if not, then obviously drawing a diagram, if it relates to a shape, is something that's worth doing. Things that relate to a graph, maybe if you've got access to a graphic calculator, may prove handy, so you kind of know what values you're looking for, max and minimum values you're looking for to check your answers. And the final point is show clear working. Don't rush and check for silly mistakes. It's very, very easy for you to make silly mistakes because the amount of work, because the amount of algebra you're going to be doing for these questions. So always worth running through your answers and checking for silly mistakes, and also looking at for the validity of your answer. And as I said, if you've got access to a graphic calculator, you could put your equation in and use the correct functions to find the peak and troughs of those particular functions. So let's have a look at this first example. So in this particular question, it says that the profit of y pounds is generated from the sale of x toilet rolls is given by the formula of y equals 600x plus 15x squared minus x cubed. Calculate the value of x, which gives the maximum profit, and determine the maximum profit. So with this, the first thing we need to do is, we'll go for red, is first check to see if our formula, so what we've been asked to find is to find the value of x at the maximum point. So in other words, what this is asking me to do is to find the x value of the maximum stationary point. And also in the last part, which is determine the maximum profit, is what I then need to do is sub the max stat point x value into the original formula, and that's what our step is going to be. So let's selecting a different colour pen to get started with. Let's go for pink. Right, so from this, the first thing we need to do is to find our differential. So looking at the original formula that we've got here, I can see I've got no square roots, I've got no fractions, so I can go straight into working out my dy dx. So I've got 600x plus 15x squared minus x cubed, and if I then work out what dy over dx is, it's going to be 600 plus 30x minus 3x squared. Now to find the stationary point I need to make dy dx equal to 0, so I've got 600 plus 30x minus 3x squared equals 0. I'm just going to stick that all onto the other side, so I've got 3x squared minus 30x minus 600 equals 0. As I'm solving, I can divide everything by 3, so I've got x squared minus 10x minus 200 equals 0, and if I go on to solve that, I'll get x equals 20 or x equals minus 10. So what I found here is that these are the x ordinates of the stationary point. Now, if I didn't have any knowledge of what this graph would look like, I know it's going to be a cubic graph, but also a negative cubic graph, then I could probably say straight away which is going to give me the maximum stationary point and which is going to give me a minimum stationary point. But it's always good practice to prove which is safe. So to check which is, to find our max and min stationary point, what I need to do is do the second derivative. So if I then work out the second derivative of d squared y over dx squared, and again I'm going to be differentiating this, I get a value of, and it's going to be 30 minus 6x. Now from this I then now want to work out which of these two values here will give me my max and minimum value. So if I was to try d squared y dx squared where x equals minus 10, then that's going to give me a value that's greater than 0, which is going to give me a minimum point, which is what I don't want. But if I then try substituting the value of x equals 20, then that's going to give me a value of less than 0, which is therefore going to give me a maximum stationary point. So the maximum, so the x value I want in this case is x equals 20. And so that kind of ticks that box there rather than tickles. So the next thing we then need to do is work out the maximum profit. And how do I work out the maximum profit? So what I need to do, so for the maximum profit, all I need to do is substitute x equals 20 into the original formula, which is this here. And again, it's very, very easy to get confused because you've got formulas all over the place. I've got an expression for the second derivative, I've got an expression for dy dx, and I've got the original equation, but it's important that we substitute it into the original. So I've got 600 times 20 plus 15, 20 squared minus 20 cubed. And as you can see, I've put it in brackets. When I this is how I'm going to enter it on my calculator. And again, although the brackets don't really make much sense, if x was a negative number, then obviously it then causes some complications depending on how your calculator works. So if I enter that into my calculator correctly, I get an answer of £10,000. So my two parts of this answer is x equals 20 and the maximum profit is £10,000. So in our second example, here we've got a plastic bar that's in the shape of a cuboid with a length of L centimeters is to be made with a rectangular cross-section of width 2x centimeters and a height of x centimeters, and the external surface area of the bar is to be 75 centimeters squared. So in the particular first part, the question is asking me to show that L equals 75 minus 4x squared over 6x. B is then deduce the volume of the bar is given by V equals 25x minus 4x cubed over 3. Then we need to find the expression for dV over dx, and then finally, given that the volume of the bar has to be a maximum, calculate the value of x and find the maximum value. So how this relates to the previous example is that part D was what we were asking for, but in this particular question we've been asked to do a bit of working around and analyse this problem before we get to that stage. So the first thing we need to do now, in this particular question, it's quite rare that there isn't a diagram, so let's start off by drawing an image of what this plastic bar is going to be. I'll try and do my best to try and make it look like a cuboid. And so reading the information from this question, here we've got that a bar has got a length of L. So this here is going to be L, and it's got a cross-sectional area with a width of 2x and x. So basically what that means is that this is going to be 2x and this is going to be x. And we know that the surface area is equal to 75 centimeter squared. So from the information that's given to me, that is pretty much all that I've got. And what I've done there is I've just related it to a diagram looking at this. Now in this particular case, we need to try and, if you look at what they want us to show, which is this here, you can see that although I've got L the subject, it's using the surface area as part of the formula, which is quite explicit. So let's go about finding the surface area of this cuboid. So starting with A, the surface area of this particular cuboid is where we add up all the faces. So I'm going to have, if I just start by labeling this A, B and C, so the surface area is 2 lots of A plus 2 lots of B plus 2 lots of C. So type that in, we know that the surface area is 75. So I'm going to have 2 lots of 2x squared. I'm going to have 2 lots of 2xl. And I'm also going to have 2 lots of C, which is xl. So expanding all of this out, we get 4x squared plus 4xl plus 2xl, and I can then combine these two things together, so I get 75 equals 4x squared plus 6xl. Now in the particular question it's asked me to make L the subject, so that's exactly what I'm going to do. So we're going to have 75 minus the 4x squared, and then all I've got to do is get rid of the 6x, and how do I do that? I do that by dividing, and there I have proved what they wanted me to show. So moving on to our second part, it says deduce that the volume of the bar is represented by V equals 25x minus 4x cubed. Now for B, the volume, let's start by getting a different colour. So here for B, the volume of this bar is going to be equal to 2x times x times L, because obviously all we need to do is multiply the 3 dimensions of the cuboid to get that particular shape. So substituting that in, we've got, now if I just join these two things here together, we've got 2x squared times, now L, as you can see there's no L in this expression here, so instead what I'm going to do is, rather than using L, because I don't want to have 2 letters or 2 different variables in my formula for V, I just want 1 letter, so I'm going to swap L for this expression here. So what I'm going to do is I'm going to put the 75 minus 4x squared in brackets over 6x. So V equals 2x squared 75 minus 4x squared over 6x. Now if I expand the brackets out, now how you do this might be slightly different, but hopefully we all come to the same conclusion. So from this I'm going to get 150 x squared minus 8x to the power of 4, all divided by 6x. Now from this I can then cancel things down, so I've got, dividing everything by let's go for 2, so I've got, this is going to turn into 75, that is going to turn into 4, this is going to turn into 3. I can then eliminate an x from every single term, so that disappears and that turns to a 3, leaving me with V equals 75x minus 4x cubed all over 3. Now from this I can split this up so I get 75x over 3 minus 4x cubed over 3, and I can then cancel the 3 with the 75, which gives me 25, leaving me with what they've asked me to do of v equals 25 minus 4x cubed over 3. So from that, now that we've proved that, let's move on to C. So with regards to C, we've now asked to work out dv over dx. Well, we know that v equals 25 minus 4x cubed over 3. Now again, the good thing about these questions is that I didn't need to work out b correctly to work out c, because they've already told me in the question what v is. So even if I don't get to work out what v is for part b, I can still use that part c, and that's one of the advantages of doing this particular question, because obviously if you're not getting the equation for v, you've got no chance with this question. So from this we can then have got dv. Well, before we do that, as we've got a fraction, let's write this so we've just got a single line. So how I can rewrite the formula for v is 25 minus 4/3 x cubed. So then dv over dx, because our formula is v in terms of x, is simply going to be where we've got and it's going to be 25. I've missed out on x, there was something missing. So here we've got 25, and then 3 times 4/3 will just be 4 cubed, and there is our expression for C. So then the last part we then need to do is part D, is now work out what my stationary points are going to be. So for D, I'm just going to start here. So our second derivative formula is going to be minus 12x squared. So from this, what we can then work out is, from there, we then can substitute those numbers in. So with regards to, not E, stop there. So moving on to B, so let's get a different colour for B. So what we've been asked here is to deduce the formula for the volume. Now the volume is going to be equal to the base times the height times the width, so it's going to be 2x times x times L. Now because obviously we want to try and get to the volume formula, we don't want to have multiple letters. So what I'm going to do is, rather than using L, I'm going to swap it for its equivalent that we worked out in part A. So V is going to equal 2x squared, and it's going to be 75 minus 4x squared over 6x. Now if I then go about expanding and simplifying this, so again, because we've done numerous ways, I can go about simplifying the top and the bottom, which I can do. So or I could just expand the brackets first. Let's go for expand the brackets out first. So we get 150x squared minus 8x to the power of 4 all over 6x. Now obviously you can see that I've got multiples of 2, and I've got x's in each term. So if I simplify each of those, if I divide each number by 2, I get 75. I take away an x from each term, so I'm going to get 75x minus 4x cubed all over 3. Now if I then break this up into separate fractions, so 75x over 3 gives me 25x, and I can't simplify 4 over 3, so it then just becomes that. Now again, if you're not too sure what I did there, from this all I wrote was 75x over 3 minus 4x cubed over 3, and then I simplified this first fraction down. And so that's how we get our formula. So moving on to C. So with C, all it's asking me to do is to find the formula, find the expression of dv over dx. So if v equals, let's start off by writing C first. So C is going to equal v equals 25x minus 4/3 x cubed. So dv over dx is going to be 25 minus, and then 3 times 4/3 just leaves me with 4, and it'll be 4x squared. So moving on to D, the first thing we need to do is read the question carefully. So what the question is asking me to do is to find the stationary points, find out which value of x gives me the maximum stationary point, and then substitute that number into the original formula of the volume. So working out what the stationary point is going to be, we first need to do 25 minus 4x squared is equal to 0, which if I then go out to rearrange this, so I've got 25 minus 4x squared, or say equals 4x squared, and doing a bit of rearranging, so we've got 25 over 4 equals x squared, so x equals either minus 5 over 2 or positive 5 over 2. So these 2 points here are the x ordinates of my stationary points. Now the next thing I then need to do is find out which of these 2 points will give me my maximum stationary point and which one gives me my minimum stationary point. So if I substitute those into my second derivative formula, which I need to work out, so from this, working out our second derivative of this here is going to be minus 8x squared. So from this, what we then need to do is substitute our numbers in. So I've got dx squared, and then I'm going to substitute 5 over 2. So I'm looking for where it's going to be, it's positive, so that's going to equal minus 20. So there I have got my maximum stationary point. So maximum stationary point when x equals 5 over 2. So from this, my x, to calculate the x value, so here it's just worth, so x equals 2.5 or 5 over 2. And then to find the maximum volume, what I then need to do is substitute 2.5 into the formula of the volume. So V equals 25 times 5 over 2 minus 4 lots of 5 over 2 cubed over 3, and if I type that into my calculator, I'm going to get an answer of 41 2/3, and as its volume, the units are going to be centimetre cubed. So as you can see, it's about reading the questions carefully, trying not to get too confused about what it is you've worked out, because as you can see from my set of solutions, and the fact that I've used different colours kind of emphasises, but if you're just using one, you can see it's a bit of a mess. I've not just carried on forward the last bit of work that I've done, I've had to retrace some of the work that I did previously in the previous parts of the question. So it's always worth making sure you're understanding what you're doing and understand the steps, and try and develop your own set of steps of working these types of questions out. And then what you can then do is relate it to what is being asked, and you can then pinpoint at what stage have you been given information, what more information do you need to work out, and you can go from there. So hopefully this is just a few examples and it makes sense to you, and if you've got any questions or would like some more practice questions on this, feel free to drop me an email at 162maths@gmail.com.